Chair of the Board, Professor Andrew Coates. Thanks, Andrew.
Thank you, Johnny, and welcome everyone. We all know what a great shame we cannot meet in person. We will definitely try and do this next time. My name is Andrew Coates, and it's very great pleasure and pride. I'm chair of this very exciting company, and it's great to have our small but absolutely dedicated and hardworking team, as well as those of you out there, our family, our partners, our shareholders, the people who have trusted us to take this company forward. I'm very excited to be here and to present to you as chairman. Let me give you a little bit of background about myself and why I think ESN Cleer has a very bright future. If I could have the next slide, Johnny. So just as a background, I am a Melburnian, Melbourne born, spent my childhood here. I did train in medicine as a cardiologist in the UK at Oxford and Cambridge, and I've worked backwards and forwards between the two countries in subsequent career in heart failure that spanned some 40 years. I've been a clinician, heart specialist, head of cardiology at Europe's largest cardiac hospital, Royal Brompton Hospital, and head of cardiology at Imperial College London. And I've treated very many hundreds, thousands of patients with heart failure. When I started, as I'll come to, heart failure was a desperate condition. It's now still a very serious condition. We've made huge progress over that 30 to 40 years. I've had an extensive clinical research career with about 1,500 publications. And for those of you who follow the research area, about 120,000 citations, an H-index of 145. But I've also taught a whole cadre of excellent leaders in the heart failure world. We've taken a new approach, which is to look at heart failure as a condition that affects the whole body and not just the heart, triggered by heart damage, but it leads to a very wide array of abnormalities in all the systems in the body, affecting everything from the muscles, the bones, to the brain, the immune system, and even fat tissue. I've also been very interested in complex systems. So I got tempted into the dark side of administration, and I've been a university leader. I've been Dean of Medicine at University of Sydney, Deputy Vice Chancellor of Sydney University, as well as Vice President simultaneously of Monash University in Australia and University of Warwick in the UK. I've also been CEO of the Norwich Research and Innovation Park in the UK, UK's largest research incubator park. I've also very proudly believed that I can make a slight claim to be an entrepreneur. With 30 patents, I've founded 3 companies that have gone on to success. I've listed them down the bottom there. The first one I list was the most recent deal, and that was a small medical device company we started in the US about 3 years ago. And that we've just merged that with a larger medical device company, delivering 16 million for the initial investors, which is about a 100-fold increase on the investment over 3 years. So although not huge numbers, we're very proud of that, as well as a 100 million pound deal for a UK company that I started about 5 years ago, which is seeking a treatment for cancer cachexia. That's the wasting condition of skeletal muscle that affects advanced heart failure, as well as a much larger deal we did with Bristol Myers Squibb from an early company that I started about 15 years ago, looking at oncolytic viruses, cancer treatments. And a lot of those, not all of them, came out of patents I did while at Imperial College and subsequently. I've also been involved with a lot of clinical trials in heart failure. Chairman of the steering committee or member of about a dozen or so of the major trials that have led to some of our proven treatments. I've been on the last 2 major heart failure guidelines in the world, the European Society of Cardiology guidelines, and I'm presently president of the Heart Failure Association, which is the largest heart failure professional society in the world, headquartered in Nice in France. And I'm very proud that also in terms of my teaching, that 3 of the 5 most recent presidents of this association, in addition to myself, are 3 of my direct students. So we've really had quite an impact on the development of this field. But I've also taken that time to be, I believe, a trusted advisor to big pharma as well as device companies in this world. We need industrial collaboration to really take medical science further forward. And as you'll hear later, This we're also taking forward in ESN Cleer by working with academic partners, and that's been recognised by government with awards of significant research funding to allow this commercial academic collaboration. I'm also a trained company director with MBA from London Business School, fellowship of the Australian Institute of Company Directors, as well as the Institute of Directors in London. And I've been on board director years, more than 50, as well as chairman of 3 separate companies. I believe in ESN Cleer because from the first time I was introduced, I could see they were sitting with a sparkle of something really unusual, which is a novel way of looking at heart failure. And I hope that I've also contributed to some of the new ways that we're grappling this huge, chronic, long-term problem with really innovative thinking and approaches that are creating major opportunities. If I could have the next slide. So I'd like to just give a little bit of background of our company is focused on coming up with solutions for heart failure. Heart failure is a huge global burden. Over 60 million patients worldwide have heart failure at any one time. About 1 in 5 of us will develop heart failure in our life because it is a disease that affects older people, and as we're living longer, we're more likely to develop heart failure. It is the most common reason for a person over the age of 65 in the developed world to be admitted to hospital. And when they come to hospital, they stay longer than almost any other condition, and it's the most expensive single hospitalization cause in developed healthcare systems. There's also a very high risk of being rehospitalized within a few months of discharge, and hence we still haven't worked out ways of stabilizing these patients entirely. And that's a major unmet need, which is identifying people who are just on the cusp of having an acute deterioration that forces them to come to hospital as an emergency. About a quarter will be rehospitalized within a month of discharge, and that's a huge economic healthcare cost burden for modern healthcare systems. About 50% of patients with heart failure will die within 5 years, which makes its prognosis worse than more than half the forms of cancer in the modern world. Now, that sounds bleak, but as I will come back to, when I started training as a medical student in Cambridge, it was far worse than that. About 87% of people die within 5 years. So we've taken 5-year survival from 13% to 50%. So that's really a 4-fold improvement in survival, but still leaves a very substantial burden of disability, mortality, morbidity that we aim to help break down step by step with our innovations. Next slide. So where was the situation when I was a medical student? In Cambridge in the late 1970s, early 1980s. And at that stage, it was a very prevalent condition. The population wasn't quite so old. And it was a condition that we all recognized was a severely symptomatic condition. Patients gasping for breath, swollen up with intractable swelling and edema, severe fatigue, dizziness, a fear of death, horrible, horrible illness. It caused multiple hospital admissions, and a patient would often be in hospital for weeks at a time. Survival was worse than almost all the forms of cancers prevalent at the time. Next slide. But probably the most scary thing was when I was a medical student in Cambridge, we were taught not to tell the majority of patients they had heart failure because there was nothing we could do for it. The only 2 treatments we had in 1979 was digoxin, an extract of the foxglove that had first been described in 1798 by William Withering, and water tablets, diuretics, to relieve the swelling and some of the shortness of breath. There was nothing that changed the life course, the disease progression, the survival of these patients. And that was despite decades of work over the 60s, 70s, and 80s. But then some very exciting new thinking came along, which turned the old paradigm on its head. We had for decades been trying to address what we thought was the central problem of heart failure, a weak pump incapacity of the heart. And we did it by developing drugs that made the heart beat more strongly. Highly logical, but unfortunately, it never worked. They could feel better for a few days, but then death rates went up. It was like flogging a nearly dead horse. And then some really innovative thinking turned things on its head and said, maybe the problem is not to drive the pump harder, but to make the rest of the body allow the heart to not have to work so hard. So we flipped around and developed drugs that relax the arteries so the heart didn't have to work so hard. Next slide. And that entered an era of fantastic success. You see there from 1986 through to 2021, each of those little boxes is a separate major clinical trial of average size of 2,000-3,000 patients that have proven statistically a reduction in either total mortality or a combination of mortality and the risk of an emergency hospitalization. Endpoints that are hard endpoints that payers will pay for. So you see how much success we've had. 20 or 30 trials, proven 10 separate treatments, some of them well known to you, ACE inhibitors, beta blockers, aldosterone antagonists, the most recent blockbuster sacubitril/valsartan, and then an entirely new class, the SGLT2 inhibitors, anti-diabetic drugs that have reduced death rates in heart failure. So we have had fantastic success over the 20 or 30 years, but we still have taken that survival from 13% to 50%. We need to get the other 50% under control. Next slide. And what is the issue? Why do we still have such a large unmet need when we've been so successful? Well, the initial success I showed you covered three problems. That the success hasn't been for all heart failure. It's only been for half of heart failure. Heart failure has two little subdivisions in it, two big subdivisions. We have concentrated on heart failure caused by a big heart with damaged heart muscle that simply doesn't pump strongly enough. That's called heart failure with reduced ejection fraction, HFrEF. There is another type that's much more common in older people where the heart muscle gets stiff due to maybe chronic high blood pressure, and that heart doesn't pump, not because it can't squeeze, because it can't relax. It's an ossified, stultified, resistant heart. It fails to relax, so it can't pump the blood around for an entirely different reason. We have had no success. There is no approved drug for this half of heart failure. Half of all heart failure, as yet, no approved drug. Just an inkling that we've had the first positive trial in the last few months. The second reason is that heart failure is a clinical condition that we only recognize by seeing a pattern of symptoms, signs, and observations. There is no diagnostic test that can tell me whether a patient with early forms has heart failure or not. So we tend not to even recognize patients until they've presented themselves with a near-death experience with a risk of dying of 25% or more by being admitted to hospital in the middle of the night in emergency. We want to get those patients before they have that life-threatening experience. And that's another huge group of patients in a condition we're now calling pre-heart failure, which is what they have just before they have that catastrophic deterioration. And thirdly, we can't identify these patients because we don't have the diagnostic test. If you like, in the modern parlance, we don't have the rapid antigen test for heart failure. And that's one of the areas that ESN is making really hard efforts to come with great success. Next slide. So where are we focusing? Well, initially, back in the late 1970s, we were concentrating on heart failure. And if you see there, we've got three sections in the heart failure spectrum. Pre-heart failure, HFrEF, that's the big baggy heart that doesn't pump properly, and HFpEF, that's the small stiff heart that doesn't fill properly. We really concentrated the one in the middle. We ignored the other two almost entirely. And down in the bottom left, you've got little diagrams showing the difference between those three conditions. But now we have the opportunity with developing new treatments to perhaps target the half that we've been unsuccessful for, the HFpEF group, as well as that huge group of patients who are on the breach of developing heart failure, who will almost certainly respond to some of our treatments if only we could identify them accurately. And ESN Cleer has come up with a fantastic strategy for that. If I take them in turn, the HFpEF, is a problematic group because it's not a single illness. There are multiple diseases that can lead to that. The aging process, fibrosis, inflammation, the effects of obesity, the effects of chronic hypertension, infiltrative diseases such as amyloid, almost like a dementia-like process affecting the heart. And all of these probably will respond slightly differently to different drugs. So what we're developing is what are called companion diagnostics, tests that can be applied that can pick out a proportion of these patients who are very highly tuned to respond to a particular drug. So instead of just giving the drug to everyone, hoping it'll work on average, we find patients who are uniquely susceptible to the improvements inducible by that drug. And that strategy makes proving the benefit much easier. It makes it a much tighter treatment option, and it's something very attractive to healthcare systems because they don't waste money giving drug to patients who will not respond. The second very major area is pre-heart failure, and the issue for that is a big clinical problem. I, as a cardiologist, might get referred patients with a family history of heart failure. Perhaps they're slightly short of breath. They want to know, is it heart failure? And it's not heart failure until they've had a major illness, because we need to document that the heart has caused severe congestion. But if I could have a diagnostic test that tells me this person is at an actionable risk, there's a high likelihood they'll develop heart failure within the next 3 to 6 months, then I can do something. And as yet, we don't have that test, but we have got some very exciting scientific results coming out that we believe we're on the cusp of proving a biomarker panel that can identify patients with such accuracy that I, as a cardiologist, can do something about it. And the regulators and the healthcare systems will pay for such a treatment because it prevents disease rather than simply waiting till it's been forward. So next slide. We have recently developed, I set up an association between all the major heart failure societies of the world to come up with an applicable definition of heart failure and define where the issues are in identifying heart failure. And here, 2 simultaneous publications. This was quite an effort because we involve the Australian Heart Failure Society, the Australian, New Zealand, the Canadian, the Chinese, the Indian, the American, and the European, with about 35 authors. And we managed to get them all to agree on one definition of heart failure. Next slide. And the really important thing we did was identify stages. Down in the bottom, you see symptomatic heart failure, which is what we started talking about. But very importantly now, clearly identified for the first time, stage B, pre-heart failure, is documented as a separate disease for which yet we have very few approved treatments. The only group we have are the SGLT2 inhibitor drugs, the gliflozins, specifically only to prevent heart failure in patients with diabetes. We have nothing for the broader group who don't have diabetes. And that's where we believe one of their major steps forward will arise from. Next slide. So our strategy in ESN Cleer is to take this traditional pathway, which requires a patient to be admitted as an emergency before the penny drops what they've got. We then do expensive evaluation and we put them on those 8 or 9 treatments that are having a good effect, but often we give too late. Next slide. What we'd like to shift to with ESN Cleer's technology is a series of biomarker panels that can identify 3 things: an imminent risk of heart failure, or what we call pre-heart failure. Also, we can identify patients highly likely to respond to particular drugs, and we can break down that large, difficult group of HFpEF patients into smaller subset who will particularly respond to certain drugs. In doing this companion diagnostic, we save the healthcare system money by targeting drugs precisely where they're needed, and we can also rule out patients at high risk of side effects. But also there's another advantage, a commercial advantage, is if you combine a diagnostic test with a drug, then you lengthen the patent for the drug quite dramatically. So there's an incentive for people to invest in the clinical trials so we can bring these potential treatments benefits to the market, which gives huge competitive advantages.